right, my name's Eddie Obrupta. I'm from Raptor Maps, and today I'm going to show you flying a DJI M210 drone for solar. So we're here at Greentown Labs. It's the country's largest incubator for clean technology, and because we're at Greentown, our entire roof has solar on it. So today, essentially, I'm going to show you how to set up a flight plan using the DJI M210. That works best for inspecting solar farms. So this is this will serve as a example. Obviously out there when you're working, the solar farms or photovoltaic plants are going to be much larger, but this is a great little test bed to show you how to do it. So today I have the DJI M210. I have our Cendence controller here, and I'm actually using the iPad. So we typically recommend DJI's Ground Station Pro, and that has some of the best automatic flight settings for flying your drone over a solar farm. So again, we do have our display from DJI, but it's Android. So we're going to use the iPad today with iOS that runs Ground Station Pro. So what I have on here and what you can see is that I essentially have our roof outlined with a polygon. And with that polygon, I'm setting an overlap of 80% front lap and 20% side lap. So that means that we're going to spend a lot less time inspecting because of that side lap is so low. So I have it just plugged into our controller. I'm going to set up the mission here, and then once I set it up, we'll go from there. All right, so we have Ground Station Pro here. What you're looking at is that we have Greentown roof, and Greentown's roof we have outlined in this polygon, and you'll notice that we're doing we have the Zenmuse XT 13mm. However, we're flying with the Zenmuse XT2. That's okay though. Ground Station Pro works fine with that. The other important settings to note is perpendicular to main path. So essentially the drone's gonna be pointed north and crab walk from side to side as it flies across these green paths. That's really important and what we're gonna need for our analytics. We also have capture at equal time interval. You can also use capture at equal distance interval, but equal time interval works just as good. The other thing we're gonna have to set here is your speed and altitude. So you typically, for doing a thermal inspection solar, you're going to want to set that shutter interval to 2 seconds. It looks like you can adjust the speed, but there's no way to actually adjust speed. You have to click this interval and get that set to 2 seconds. Also, you'll want to notice that your height here, so the altitude is super important. If our typical inspection for most people flying solar is going to be about 130 to 140 feet above ground level. Today though, just for today, for this video, we have special consideration because we are flying in Class B airspace with the land system, so we have authorization to fly. We're close to Boston Logan. However, the surface, the ceiling restriction is 150 feet today, and we're standing on a roof. So I'm going to actually set this altitude to be 110 feet. But remember, typically when you're outside a solar farm, you're going to want to set this to about 130 to 140 feet above ground level. Okay, if we go into the advanced settings, you'll notice that we use 80% front lap and 20% side lap. The 20% side lap is going to save you a ton of time flying. So just for this rooftop here, if we set it at a 80 or 90% overlap, that is significantly increasing our flight length exponentially. So we're going to keep that basically, that would take about, this is a very small roof, so it would take 150 photos, but if we go down to 120 to 20% overlap, we're only going to take about 30 photos. So that percent change is going to be similar when you're out there at the big solar farms and save you a ton of time, especially if the solar farm is hundreds of acres. The course angle, that's another important variable to set. So essentially the course angle is these green lines. You want them to run parallel with the solar panels. So the rows of solar panels, you're going to get those lines to be parallel. So right now we're pointed north. So the sun is down in the south, right? So all the solar panels are tilted up. So we want to make sure that we're going along with that tilt angle essentially. So There's two ways to do it though. There's 180 degrees, but I could also flip this 180 degrees. However though, if I did that, the drone would be pointed south and all of the solar panels are tilted to the south. So in order to keep the drone pointed to the north, we're gonna set this at, for our rooftop here, our course angle is about 160 degrees or so. We're gonna set the end of the mission to be hover, so that way when the mission finishes, I'll fly the drone manually back to the landing position. You can also use return to home, but for our roof situation here, I think it's better if I land it manually. And those are the basic settings. I think pretty much all the settings you need to know to successfully set up a flight plan to inspect a solar farm using 20% side lap. Okay, so a lot of questions around which flight apps and which file formats we get quite often. And the answer is when you're inspecting solar, we always want to use the radiometric JPEG. So we have Ground Station Pro, which we're using. So that sets up our flight path and how we're going to fly. However, in Ground Station Pro currently, there's not many options to set up thermography settings. But luckily, we can set those up in DJI's XT Pro app. So in the XT Pro app, let me just get you back to the screen here. That's this red icon here, this XT Pro app. We can set up a lot of thermographic settings for the camera. So, okay, so you can see me, I think. 1 second, let me just open that app. Let's let it load. Okay, great, you can see me. Hey, how's it going? Now, inside the XT Pro app, we can set a lot of settings. So what we want to make sure we do, if we open up this tab on the left, again, this is on the iPad. Palettes, there's a lot of great color palettes, but for inspecting solar, we're always going to go with white hot. That just keeps it simple. We're going to be using software later. You could also choose a different color palette in post-processing, but while you're flying and out in the field, white hot is a go-to for us. Isotherms, you don't need to set any of those, so just leave those off. And then I'm also going to walk you through some of the settings up top here. There's magnification. We actually just want to leave that at 1x. So while you're flying, keep it at 1x. That's also going to make it a lot easier for post-processing later and not getting confused on where your photos are. Spot meter, we can turn that off. We can keep the field correction as it normally is. There's also these different modes. There's MSX, picture-in-picture, and visible. We want to keep this at MSX. And although it's set to MSX so we can see the thermal picture around the full screen, we don't want any of the MSX settings for solar. So if we open settings, you're going to see that there is MSX strength. We're going to keep that to off. Again, if you put it on a different setting, it can be corrected in post-processing, but for solar, it's best to keep that off in order to see anomalies and such the easiest. The other important setting is radiometric JPEG. We're not shooting video, so the video format doesn't matter. We also have auto flicker. We can leave that to auto. We don't have to worry about MSX offsetting. We're going to keep the shoot mode to single. And all the other settings exclude none. The gain, we keep automatic. Scene, there's many different options here. We're going to just leave that at default. Temperature scale, up to you no matter what region you're in. I'm here in the US in Boston, so I'm going to leave it at Fahrenheit. Critically low battery warnings, those are up to you, however you need to set those. Also in thermal, there's a couple custom settings that you can have. I don't really need any of those today, so I'm going to leave those mostly all set to not assigned or off. So from this standpoint, in DJI's XT app, everything is set up for the camera. We have radiometric JPEG. We set the color palette to white hot. We're on a 1x magnification. We have MSX, so we can see the whole thermal image. However, I set the MSX level to low, or actually none, which is going to make it easiest for you to see thermal anomalies. At this point, we don't need the DJI XT Pro app anymore. We can actually open up DJI GS Pro. So I'm going to open up DJI GS Pro. Make sure that gets all set up again. Okay. And as you can see, I have my polygon boundary. I've set all the settings to how I want them. And at this point, we're ready to fly. So when we fly, it's going to take off and it'll start taking pictures in radiometric JPEG following an intervalometer. So at this point, let's take off. Okay, now this is something, I have the XT2 camera and I have the M210 RTK. So up in your, if you have a problem here taking off, you can go up to this GPS RTK setting and you want to turn off RTK, like I have it off here. Now, unless you are using RTK, then you can turn that on, but that also can get people tripped up sometimes. So let's go back to flying. Because this is the XT2 camera, we get this operation failed warning. The camera still functions and works just fine. As I mentioned before, I am in Class B airspace, so I do want to unlock this fly zone. I do have authorization from the FAA through the Lance system, so we are fully authorized to fly. So I'm going to unlock that. And at this point, we're ready to start flying. Let's start to fly. Now I'll put my hands on the controller. Okay, so the drone's taken off. We're going to altitude. And we're almost at 100, our flight specified altitude. We can see the drone starting to fly. I'm going to pop this open so you can see. It's going to line itself up nicely. There we go. Okay, you see how that image is taken? So we're lined up with the solar panels and the drone's pointed north and we're taking pictures from left to right. We have a little bit of glare, but that's okay. And we're taking photos now. Right now, you can see we're taking photos every 2 seconds, just as we specified. And that drone is going to basically stop there. It does its walk from left to right, make sure we capture all the panels in the field of view. The drone gets to the end, it stops, and then so that's your front lap, right? We're taking 90% front lap, or 80% front lap, then it moves down, so we'll have 20% side lap, and it will make the next pass. So we have a little skinny roof here, but this is showing you how to do this flight path pretty much. Now you can also, if there's a lot of tilt on the solar panels, you can also tilt up your camera a little bit to get better lined up with those panels. So that's just something I manually adjust on my Cendence controller. And at this point, we're doing a fully automatic inspection. I'm not flying. I'm just monitoring, keeping track of my airspace, making sure that there's nothing in the way. But pretty much the drone is doing its thing and capturing really good quality radiometric imagery.